Okay, good morning. So this morning we're going to be doing a mixed review of exponential functions and logarithms. We have some worksheets to work with. So have a go at our do now. Right, let's have a look at how we do these ones. So what we need to do is we need to express in terms of y the first two. So log 8 of x squared is 2 log 8 of x, which is 2y. Log 2 of x is equal to log 8 of x divided by log 8 of 2. So 2 is the cube root of 8, 1 over 3 as an exponent. That gives us this. So for b, this is term I, so that's 3 times 2y. This is term II, so that is plus 3y. This gives 9y equals 6. Y equals 2 over 3. This implies that 2 over 3 is equal to log base 8 of x, which tells us that x is equal to 8 to the 2 over 3, which equals 4. Any questions there on that one? No? Okay. Have a go with this question. Put your answer in the chat when you're done. Right. So I'm looking at this question, and I've got two equations to solve the equation system. So the first thing I notice is that they're in different bases. One equation is in base 2, and the other equation is in base 4. So I'm going to change that. And then I have to think, which one do I want to sort of change? I like the idea of changing the second one because the bits inside the logarithms is a little bit smaller and less complicated. So I'll play with that one first. I'm going to change that to a base 2 to match it to the first one. And then I'm going to think about that. Is that going to help? And 2 and 4, these are either squares or square roots. So I know that the base is going to simplify out to a number. So let's dig into that and see where it takes me. So I have log 4 of x plus log 4 of y. I'm going to take that and I'm going to convert it to base 2. So I get log 2 of x over log 2 of 4 plus log 2 of y over log 2 of 4. Now log 2 of 4 is equal to 2, isn't it? So that is a half log 2 of x. Log 2 of 4 is equal to, plus a half log 2 of y, which is equal to a half. Let's take that equation and multiply through by 2. And we get log 2 of x plus log 2 of y is equal to 1. We can take the other equation, which is log 2 of y is equal to log 2 of 3 minus 2x plus 1. Form these two up into an equation system, and then I'm going to subtract one from the other. So subtracting one from the other is going to cancel. The log 2 of y, so we get log 2 of x, and then 1 minus 1 cancel. This is going to be minus log 2 of 3 minus 2x. Okay, I'm just pausing to think now about how I want to proceed with this one.
Wait, sir, what part did you choose to subtract?
Equation 2 from equation 1. Okay, I'm thinking about the minus sign and what to do with it. I'm going to move it onto the left-hand side and make this 1 over x and leave this as 3 minus 2x. So I'm going to multiply through by x. And then rearrange to the quadratic. Then I can factor that to 2x
Sir, isn't it supposed to be minus 2x squared plus 3x minus 1? Oh, you added both sides.
I think that's good.
Wait, sir, I'm confused. How did you get 1 over x?
This minus sign here, I can move to the other side by multiplying both sides by minus 1. Then I can move it up onto this x here as x to the power of minus 1, and it gives me this 1 over x.
Right.
This gives me minus 3x plus 2x. Yep. Okay. So I factor it like this. It gives me x equals a half, x equals 1. Then I need to figure out what my y's are going to be, given those. So I'm going to use this equation here to calculate my y's. I'll start with the 1. Just take off some of those little dots. So trying the x equal to a half, putting it in the equation, log 2 of a half. That's 2 to the minus 1, so that's minus 2. Let me do it. Log 2 of 2 to the minus 1. Log 2 of y. Minus 1 plus log 2 of y equals 1. Log 2 of y equals 2. Two to the 2 equals y, implies y equals 4. Let's just express the answer neatly. So when x equals 1, y equals 2. When x equals a half, y equals 4. These are our solutions. Any questions on this one?
Sir,
Yes.
when you were getting the 1/2, you got 1/2 of log 2x and then 1/2 log 2y.
Here?
Or it's higher up.
Oh, here?
Yeah. What did you do after?
So I've got this equation here, and I write that one down. So then I use the change of base formula here. Now log 2 of 4 is equal to 2. So these two here in the denominators become 2, and I just wrote them there at the front as halves. And then at this point, I'm playing here with the left-hand side of the equation until I get to this green dot there, and then I pop up the right-hand side of the equation. So I've simplified this down to this, and at this point I multiply through by 2, and it will cancel. There's a 2 in the denominator of each of the 3 terms of the equation, and it cleans this one up and gives me this new equation here.
Okay. Sir, will this recording be posted on Google Classroom for us as well?
Yes.
Okay, thank you.
Okay, let's have a go at our next one. Put the answers in the chat when you're done. Okay, so just sketching the problem, it looks like this one. The other one is going to come down like that. It's going to go through, it's actually going to go through there at the asymptote. Sorry, I missed a little bit. So this is going to go through 0, 1. So our point A is here. So in B, we need to show that the x-coordinate of A is a solution to the equation given. So we have to basically show where has that equation come from. So we've got two functions. We've got 2 to the minus x is equal to 2 to the x plus 1. We have this function here, 2 to the minus x, and then this function here. These two are equal at this coordinate. So this is 2 to the x to the minus 1, which means 1 over 2 to the x. So multiplying through, we get 2 to the 2x plus 2 to the x. And then we can just rearrange it all now to 2 to the 2x plus 2 to the x minus 1 equals 0. And that shows that that is a solution to the equation for point A. Show that the y-coordinate is this. So here I might get a bit stuck. I'll have a bit of a jab at it. I'm just thinking through. I need to get a numerical solution, so I'm going to have a go at solving this equation here. I'm going to let t equal 2 to the x. Therefore, t squared plus t minus 1 equals 0. That's going to have all sorts of nasty solutions. So I get t plus 1 over 2 squared minus 1 over 4 minus 1 equals 0. T plus a half squared is equal to 5 over 4. I'm going to go back and look at what we've got. Look, we got a root 5. That's nice. Square root both sides. T plus a half is equal to root 5 over 2. Subtract half from both sides. T is equal to minus 1 plus minus root 5 all over 2. So that means 2 to the x is equal to that. So using this equation here, which has a 2 to the x in it, it's 2 to the x plus 1. So y is equal to 2 to the x plus 1. So y is equal to minus 1 plus minus root 5 over 2 plus 2 over 2. So add the 2 to this, and we're going to get a plus 1. So 1 plus and minus root 5 over 2. Let's go look at what we're aiming at. So a half bracket 1 plus root 5 is a solution. There we go. Any questions there on that one? Okay. That's it for
Sir,
today. Let me just stop the video.